Morning students. We shall start chapter 6, work, energy, power. In this class we see that what is work and how to calculate work, and what is a dot product, how to calculate a dot product. Let us see. Generally we see the terms called work. We usually do work at the time of exams. A farmer will do work like ploughing the field. A construction worker works it, and particularly if somebody person like works for 10 hours, you can think of that he has more stamina. It's such like many examples we see in general terms we use work. I have work. But coming to physics, how to say, how to define work and what are the units, how it is related to force and displacement. I should call it as displacement because both are vectors, F vector and here S vector. So we shall go with a simple terms. Before going to start, we shall see that what is scalar, what is vector. We are very much familiar with the scalar and vector in the chapter 4. Right now we are observing now scalar product, vector product and scalar product. How to calculate? This is also called as dot product. This is also called as a cross product. So symbol is a dot, this is a cross, right? Generally let consider vector A is there, vector B is there. Two vectors make an angle theta, make an angle theta. Now how to write dot product? There is a dot product between the two vectors will be giving as a result as a scalar number, which is called as A into B cos theta, or in other simple terms we will write it as A dot B is equal to mod A mod B cos theta. You know very well, mod A is magnitude of A, mod B is a magnitude of B, right? And how to write this again? We shall go within a precise manner. A dot B is equals to A into B cos theta or B into A cos theta, B into A cos theta, both are same. So A dot B is equal to B dot A, which is also obeying associative law, distributive law. This is called as commutative law. Now how to write distributive law? A dot B plus C dot is equal to, expand it, A dot B plus A dot C. Okay. Now suppose A into 2B, A into 2B, how do you write? This is, so 2 is taken common and 2 into A dot B. Similarly we write it as A into lambda B is equal to, lambda is taken outside and A dot B. Okay, where it is, even it is positive number, negative number, we can make it like that. Okay, we can take common. And here what is I and I? You know very well, I is a unit vector which represents along x direction, And another I vector is there which is also representing in the same direction like x direction, which is equal to 1, because how to write this one, mod I cos theta. What is theta? You know where will mod I is 1, mod I is 1, cos 0, because I vector to I vector angle is 0 degrees. So, simply 1. Similarly, I write it as j dot j is equal to 1, k dot k is equal to 1, right. Now, we will see I dot j, I dot k, you can understand. I dot j, mod I, mod j, what is the theta? I vector to j vector, theta is 90. You know very well, cos 90 is 0, right. Now, how to write the dot product of two vectors, vector A and vector B. So, vector A can also be represented as in terms of components, x component, y component, z component into bxi, byj, bzk. So, this is the actual form we have seen in the last fourth chapter. A can be written as axi plus ayj plus azk, bxi plus byj plus bzk. How do I write generally? Axi in dot into bxi, byj, bzk plus ayj dot bxi, byj, bzk plus azk, bxi, byj, bzk. See, I dot I only 1 and remaining 0. So, simply, and j dot j is 1, remaining all zeros, k dot k is 1, remaining all zeros. So, ax bx plus ay by az bz. So, vector A, vector B, right. Now, this is simple where you will get answer to be like scalar only. So, vector dot vector is equal to scalar. Let us see with a simple example how this can be. Suppose I plus j plus k dot I minus 2j plus 3k. So, how to write I dot I, j dot j? What is the component here for the vector, like coefficient is 1, for I this is 1. So, 1 into 1 plus 1 into minus 2 plus 1 into 3. So, 1 minus 2 plus 3, 4 minus 2. This is called as a simple dot product of the two vectors where they have given. How to find out angle between the two vectors? Angle between two vectors. Let us see simple. Vector A is there, vector B is there. They make an angle, theta. So, first we have to find out magnitude, mod A and mod B. So, this is called as ax square, ay square, az square. This is again you know that this is bx square, by square plus bz square. We had seen a simple a dot b is equal to mod A mod b cos theta, or simply if you don't want to write mods, simply it is ab cos theta. From this, how do you write this? Cos theta is equal to a dot b by mod a mod b, or simply we can write it as cos theta is equal to ax bx plus ay by plus az bz by under root of ax square plus ay square plus az square bx square plus by square plus bz square. Now, let us see a simple term how this has come. You have a doubt, why do we write cos theta, and why should we include cos theta, or why don't we go for sin theta or some other formula. Let us see the simple cross product formula derivation. So, let us see that vector A is there, vector B is there, A and B are the vectors are making an angle theta. See, this is a vector A, see this is vector B, this is theta, right. Now, what is the shade? This is called as shade. This is a shade or a component. What is the component along A? You know that this is called an adjacent component. Now, this is called as a b cos theta is a shade or is a projection. Now, if you are considering that projection of B along A, which is equal to A into b cos theta, because projection of B is b cos theta. This is nothing but a dot b. When you want to multiply as a scalar product a dot b, one can be taken as simply scalar product is a b cos theta, right. Otherwise, simply you can take this is the a vector and this is b vector, angle is theta. Now, projection of A along B is simply a cos theta. A dot B is equal to a cos theta into B. So, which is called as a b cos theta, right. Now, so a dot B is equal to either a cos theta into B or a into b cos theta. So, this is a simple problem which is there in the example. F is given and D given. What is the angle between force vector and D vector? So, using dot product we can calculate. Here what is given? F is equal to 3i plus 4j minus 5k. Of course, shall I calculate mod of F? How to calculate? Under root of 3 square 4 square minus 5 square, which is 9 plus 16 plus 25, which is equivalent to 50. What is D is given? D vector is 5i plus 4j plus 3k. Mod of D is equal to 5 square plus 4 square plus 3 square. So, you will get the same, which is root 50. According to the formula, how do you write? F dot D is equal to mod F mod D cos theta. From this we will write it as cos theta is equal to mod a force vector D vector and mod F and mod D. how to write this? Cos theta is equal to f dot d 3i plus 4j minus 5k 5i plus 4j plus 3k. So, and what is this? Mod f is root 50, mod d is root 50. So, cos theta is equals to 3 into 5 15 plus 4 into 4 16 plus into minus 5 into 3 15 root 50 simply 50 15 cancel. Cos theta is equal to 16 by 50. So theta is equals to, you can write 4 fours are, otherwise you can do which is cos inverse of, if you do that we will get it as 0.32. So this is theta. You can use calculator to calculate this. What is projection of f on d? Suppose this is the force vector and this is d vector and this is d. What is projection? Projection is on d is f cos theta, right? F cos theta. What is f? F cos theta is projection of f on d. So f is root 50 and cos theta 0.32. You can calculate, you will get it. So this is the way where we can write a simple calculation where point f cos theta root 50 into 0.3 by 0.32. So another important one, we choose most of the times asked in the examinations as a question, what is work energy theorem? What is work energy theorem? See, I'll write the statement first, then you can we prove it. Statement. So there must be a change in observation of kinetic energy, right? The change in kinetic energy means, change in kinetic energy means initial kinetic energy, final kinetic energy, both are there. The change in kinetic energy of a body or a particle is equal to work done by the force, not on the force, work done by the force. What is the force? We can write net force. If more number of forces are there, we can consider more net force to be calculated, because when you are considering gravitational force, sometimes there may be a resistive force or frictional force or other forces, dragging forces can also be considered. In order to prove this, we will take the equation which is called v square minus u square is equal to 2as. This is seen in the last chapters. This is the third equation of motion with constant acceleration, right? What is v? V is final velocity. What is u? Initial velocity. What is s? Distance or displacement. What in the sense, in the linear motion, distance displacements are equal. What is a? It is constant acceleration, right? Now for this, what I am doing, say multiplying with m on both sides, multiplying with m on both sides. So m into v square minus u square is equal to m into 2as. M into v square minus u square is equal to 2 into ma into s. Just I am dividing left side, I am bringing it of mu square here minus of mu square here is equal to ma into s. What this represents, you know very well, second law of Newton, right? So of, so I should write simple. What is this? This is mv square. So of mv square minus of mu square is equal to force into displacement. So according to the definition of the work, the force into displacement is equal to the work. So this is what actually final kinetic energy minus, this is called as initial kinetic energy, which is equal to work. So work done by the force, where force is equals to final kinetic energy, right, which is called F minus initial kinetic energy. This is a subtraction. So this is called as the work energy theorem by using simple equation of motion. So net force is there. Sometimes if more number of forces are there, we consider a net force here, right? Now see, this example problem is there in the textbook. Now we shall consider this, how to calculate work done by the gravitational force, work done by the gravitational force. Second one, what is the work done by the resistive force, right? It is well known that train drop falls under influence of the downward gravitational force and the opposing resistive force. The latter, it is known to proportional to the speed of the drop, otherwise it is undetermined. Consider a drop of a mass 1 gram falling from height of 1 kilometer. So the distance is 1 kilometer, which is almost, it is 10 power 3 meters. It hits the ground with a speed of 50 meters per second, right? What is the work done by the gravitational force? What is the work done by the unknown resistive force, right? Now first let us choose delta K. What is delta K? Final kinetic energy mv square minus so mv square minus of mu square. Now of mv square minus of mu square. So delta K is equal to, simply it is of mv square minus 0, because it starts from 0. Now of mv square minus 0 means it starts from rest, so initial velocity is 0. Now let us calculate kinetic energy is equal to half into 10 power minus 3 into what is velocity, what is the velocity which is given, 50 meters per second. Velocity is given is 50 meters per second in the problem they have given, so which is 50 square, right? So half into 10 power minus 3 into 2500, which is simply it is equals to 1.25 joules. So now we apply work energy theorem. Work done by the force is equal to change in kinetic energy. What is the work done by the force? How to calculate? What are the forces which are acting? One force is called as a gravitational force. One is a gravitational force. And what is the other force? Suppose other forces are there. Now we will calculate first gravitational force. Work done by the gravitational force is equal to mgh. So mass is 10 power minus 3 and g is 10, height is given as 1 kilometer. So this is, so which is called as 10 joules, right? So work done by the net force, which is equal to work done due to gravitational force, work done by two other frictional forces. So work done by the gravitational force plus other forces, which is equal to delta k according to work energy theorem. So which is, what is this? Over gravitational 10 joules plus w other is equal to delta k, we have calculated, which is 1.25 joules. So w other is equals to minus 8.75 joules. So other forces means might be frictional forces or resistive forces. So work done by the resistive forces, like such forces you get it as negative, because force is one direction, displacement is another direction, so that you will get it as work can be negative.